In recent years, artificial intelligence has taken a leap forward in how systems learn, adapt, and improve. Researchers and developers are moving beyond traditional models, introducing groundbreaking systems that can refine their own learning processes. Meta's hyperagents, the Darwin Gödel Machine, Luma AI's creative workflows, and Anthropic's Claude system are a few of the latest innovations that promise to reshape our interaction with AI and its applications. Let's dive into how these advancements are pushing AI into uncharted territories. The dream of self-improving AI. For decades, AI researchers have chased a bold and ambitious goal, creating systems that can improve themselves. The idea is simple, yet profound. A machine that not only learns specific tasks, but also learns how to improve its ability to learn. This self-improvement concept has long been a vision in the field of artificial intelligence, but for many years it was considered more of a dream than a practical reality. Early theories, such as the Gödel machine, presented a groundbreaking concept where AI could theoretically rewrite its own code to enhance its performance. The Gödel machine suggested that AI could identify ways to optimize its functionality by modifying its own structure autonomously. While this was an exciting intellectual concept, it remained a theoretical idea for many years. In practice, however, the idea never materialized, primarily because no systems could achieve this level of autonomy outside of highly controlled environments, where every move the machine made was carefully monitored. Despite the progress made in other areas of AI, truly self-improving systems seemed out of reach, until now. Darwin Gödel Machine and its limits. One of the first working models to push the boundaries of self-improvement was the Darwin Gödel Machine. The Darwin Gödel Machine was designed to allow AI to improve itself by generating and testing changes to its own code. This was a huge step forward in the AI field, as it allowed systems to modify themselves in real time, particularly excelling in coding tasks. However, the Darwin Gödel Machine still had its limitations. Its design was inherently dual-layered. One part of the system performed tasks, while the other part focused on improving the system itself. The major flaw with this approach was that the improvement layer was still designed by humans, meaning it was static. While the AI could improve itself, it could only do so within the confines of the parameters set by the human designers. This led to a paradox. If one part of the AI improves another, who is responsible for improving the improvement mechanism? This dilemma created an infinite regress, where the system could never fully break free from the constraints set by its human creators. Adding more layers of improvement only compounded the issue, as the improvements would be nested infinitely. Eventually, the question arose, if every layer of improvement relies on another layer for development, how do you break the cycle and enable true autonomous self-improvement? This paradox prompted researchers to seek a more radical solution, one that would eliminate the need for extra layers altogether. Meta's hyperagents. Instead of adding more layers, Meta introduced hyperagents, a completely new approach to self-improvement. In this framework, the system is unified. It is a single program capable of modifying itself, not only in terms of the tasks it performs, but also in how it learns to improve itself. This shift is significant. Instead of simply optimizing for task performance, hyperagents can adjust their own learning processes. In practice, hyperagents have been tested in various domains. For instance, in robotics, a quadruped robot tasked with moving in a simulator was assigned the goal of maximizing its torso height. Initially, one might expect the robot to stand up straight, but the hyperagent figured out that jumping actually increases height more effectively. This breakthrough in autonomous learning demonstrated the AI's capacity to evaluate and change how it approaches tasks without external input. From robotics to research paper review, what's remarkable about Meta's hyperagents is their ability to generalize their learning across tasks. Initially tested in simple robot tasks, the system was later evaluated in entirely different domains, such as reviewing research papers. Initially ineffective, the hyperagent progressively improved its performance, eventually achieving a score of 0.710 in research paper evaluation. More than just providing surface-level feedback, the system created structured review pipelines, complete with checklists, multi-stage reasoning, and decision rules. This shift from task solving to system building in AI is a fundamental milestone in the field. Luma AI. Creativity meets automation. As AI continues to advance, the demand for creative tools that streamline workflows has surged. Luma AI is one such system that stands out in this regard. Many creatives today juggle multiple tools, editing software, video models, communication apps, making the workflow itself a significant bottleneck. Luma's solution? Introducing creative co-pilots. Instead of merely providing a new tool, Luma agents assist users in coordinating different parts of the creative process. By understanding real-world factors like motion, timing, and space, these agents can help direct the workflow behind the scenes. Whether working on video editing or refining a design, Luma agents ensure that users stay focused on the creative aspects, while automating repetitive tasks like file management and routing different tools. Claude, the computer-controlled future. A major leap in AI's practical use comes from Anthropic's Claude system. Unlike previous AI models, Claude is designed to interact with the user's computer in a more intuitive and hands-on way. It can open apps, edit files, browse the web, and even execute complex commands. Imagine starting a task on your phone, only to have Claude finish it seamlessly on your computer. This is the kind of cross-device functionality that opens up a world of possibilities for automated workflows. Claude also extends its capabilities to the developer world, where it can read, edit, and run code, automating parts of the development process. It can understand code bases, fix bugs, and even run commands across multiple terminals. This sophisticated automation isn't limited to basic tasks. Claude can catch security vulnerabilities that traditional tools might miss by analyzing how the code behaves in real-world scenarios. As this technology continues to evolve, it could profoundly disrupt the cybersecurity industry. The changing landscape of AI workflows, the power of Claude's new abilities lies in its automation of entire workflows. Tasks that once required human intervention, such as creating presentations, converting files, or summarizing emails, can now be performed autonomously. What's more, Claude doesn't just respond to prompts. It plans tasks step by step, often executing them in parallel. This marks a shift from traditional AI, which typically required manual input at each stage, to AI that is capable of managing entire workflows autonomously. In a way, Claude acts like a digital assistant that anticipates your needs and executes tasks efficiently in the background. This transformation means that businesses and developers can focus on higher-level work, while routine tasks are handled by AI. What's next for self-improving AI? The advancements we've seen in AI self-improvement, such as Meta's hyperagents, the Darwin Gödel Machine, and Anthropic's Claude, are just the beginning. As these systems evolve, they will become increasingly adept at improving not only specific tasks but also the very process of learning and adaptation itself. This creates a future where AI systems can continuously evolve, opening up new possibilities for industries ranging from robotics to software development. However, these advancements come with their own challenges. As AI becomes more capable of managing complex tasks autonomously, questions around control, ethics, and safety will need to be addressed. For instance, as AI becomes better at self-improvement, how can we ensure that it doesn't evolve in ways that are unpredictable or harmful? The future of AI is not just about creating smarter systems, but also about designing frameworks that allow AI to evolve safely and ethically. With systems like hyperagents, the Darwin Gödel Machine, Luma AI, and Claude paving the way, we are moving toward a world where AI doesn't just serve us, it learns to improve itself, driving innovation in ways we've only just begun to explore. And that's it for today's look at self-improving AI. What do you think of these breakthroughs? Drop your thoughts in the comments. If you enjoyed the video, like and subscribe for more updates on AI and tech. Thanks for watching, and see you next time.